okay, we talked about, gender and passenger class, but that alone does not look at the combination of the effects of gender and passenger class together, right? Right?
Yeah.
It's just the predictive power of gender, the predictive power of passenger class. So under regression, binary logistic, of course, you all know this already. This is passenger class and sex cat. There, I said it on the recording. Like individual predictors, right? But what if you want to know the predictive power of those together, right? Well, all you have to do is click on P class. I push control on my keyboard and then sex, and then it's right here. It's A times B. That's what brings over the combination of those factors, of those predictors, okay? So now, I mean, we wouldn't run it with these because that would be repetitive, right?
What?
So move those out.
Oh, okay. Okay.
Yeah. And there's nothing there. Good. So let's just do passenger class and sex combined, right? So we're looking at female first class, female second class, male first class, right? Hit OK as a simple logistic regression. And
you hit, just real fast before you hit control and selected both.
Yes, control
okay,
and then click both of them.
Okay.
Yeah.
Craptastic. I gotta go back and do that.
Okay, then, okay, so block one, here we are. Remember the predictive power of the model was 61.6 with nothing in it. With the combination of those factors in it, I think it was 78.7 before with the two. It's only 68.8 when you try to account for female first class, female second class, male first class, male second class, whatever. Part of the reason here, y'all, and let's just go on down. Here we go. It's only about someone's only about 2 times more likely to survive, right? As those increments go up. Think about it. I think when the Titanic was sinking, they were saying women and children, right? If I remember correctly from the movie. So I don't know if class really had an effect on that, right? Go ahead, Chris.
Oh, thank you. I was going to ask you to move your mouse, but so the constant is that's where I'm lost. What is the constant?
Okay, yeah. The constant is if everything else is 0.
Everything
That's
else.
all that means. Yeah, it's like the linear equation, right? If x is 0, where does this line cross at y?
Oh.
What we're looking at is the passenger class by sex and its exponent b.
And
right?
okay, oh, and that's why you said twice. I thought you were comparing when you said twice as much with and the arrow was in front of it, the 0.358 and the 989, and I was like, that's well,
no,
okay,
sorry.
that's where I was way confused. Okay, perfect. We're looking at the
I'm
first
drunk
line.
mouse. Yeah.
Gotcha.
Yeah. This is called drunk mouse time. Like, don't ignore my mouse. I apologize. I'm just hear the words that come out of my mouth, right? Because I do this all the time. Like I feel sorry for you now. Anyway, so sorry for getting distracted earlier. I was trying to think through a couple of other things. Does that make sense, so y'all?
Yeah.
Cool, right? Okay. All right. So we talked a little bit about latent variables last week. These things that are difficult to measure. In fact, two of my lawyer friends who work with me, one of them asked me at lunch today what we're going to talk about in class. So hey, just know in case your ears were burning, that my legal counsel cares about what you learn in this class. And I gave them the example of burnout, and they said they understood. So I'm going to take their presumed understanding of what a latent variable is, aka a construct, to mean that you understand it after we talked about it last week. Latent variables or constructs are things that are not easily measured. Even if I asked everybody in this room, hey, are you burnt out? Do you have feelings of burnout? You could say yes. I might assume that you're burnt out because of all the homework I've given you for this class. That may be a small part of it, but Jody just found out her boss got let go or left or whatever, right? So, I mean, there's always other factors at play. There's no one measure of burnout unless you're being literal, right? And you're on fire, right? Um, so the purpose of factor analysis, again, just to kind of rehash this from last week, is to understand how a set of variables is structured and how they align together. Because most of the time we have to construct these questionnaires. You talked about this a little bit in data collection, I'm sure. But those questionnaires hopefully measure what we intend for them to measure. That's called validity, y'all. And third and fourth, probably the most important, it's to reduce our data set. I could ask 100 questions to you right now about your level of burnout. Do I really need to ask 100? Or can I only ask 5 or 10? And get at the same information, right? So this is about collecting meaningful data. I'll be honest with you, if I had to ask you 100 questions to figure out burnout, you probably wouldn't respond to all of them. And it'd be very hard to collect that kind of data. So it's an efficiency thing. So for this week's example, we're going to look at an SPSS anxiety questionnaire. Appropriate, no? So there are only 8 items on this questionnaire. The first one is, and by the way, it's a Likert scale. So it's, or Likert, 1 to 5, strongly disagree to strongly agree, right? So item number 1, statistics makes me cry. Item number 2, my friends think I'm stupid for not being able to cope with SPSS. 3 is standard deviations excite me. 4 is I dream that Pearson is attacking me with correlation coefficients. 5 is I don't understand statistics. 6 is I have little experience of computers. 7, all computers hate me. And 8, I've never been good at math. Okay, makes sense, y'all? We're going to come back to that, but I just want to kind of introduce it to you. Okay, this is a questionnaire, right? So this is what we're talking about. The first thing we need to do when we try to figure out how much we can reduce a survey questionnaire or the number of items that we have, the first thing we need to do in order to go through a reduction process is determine whether or not we have sample adequacy. So we've got these questions, we've got our responses. Well, there's 2 ways that I want you to assess this, kind of on the front end, do some quality control. Remember, with logistic regression, we ran Cook's distance and the standardized residuals and had to basically, look at them after the fact, right? Remember that? So this is one of the first steps we'll run in factor analysis, but it will come out with the overall output. But I want you to look at it first whenever we finish it up. It's in the descriptives, so I'll show you how to get there. The way I remember Kaiser, Meyer, Olkin, or what we call KMO, is if we don't meet it, then we basically knock out our sample. So we KO it, right? Kaiser, Olkin, KO, easy peasy. 0.5 is bad, 0.5 or below is bad, 0.6 is kind of adequate, 7's okay, 8 is better, and then 90 and above, or 0.9 and above is really good, all right? There's another option called the anti-image, and what this does is it creates kind of like a correlation matrix, but it's intended, now think about this, y'all. You've seen many correlation matrices at this point in the 2 semesters that you've worked on this stuff. In a correlation matrix, you don't have a correlation coefficient or you shouldn't have it for like one variable on itself, right? So Eric and Eric is like a 1, right? It's perfectly correlated because I'm not perfect, but I was going to say it because I'm perfect, but I'm not. No, but like, as you go down, Jody and Jody, Kara, you should be correlated with each other. Well, the anti-image, rather, the anti-image analysis creates a similar type of matrix, but you don't have the 1 going on the diagonals. What you want to see is at least a 0.5 or above on all those diagonals. All the other Kara, Jody intersections, Monta, Chris intersections, right? All of those need to be small. If they're not small, if they're like 0.3 or above, then you might have some variables that are not very helpful to your analysis. Okay? Sound good? Okay. 2 pulse checks. I like to call them pulse checks. All right, so here's what the output looks like for KMO. As I said before, 0.9 is great. This is 0.818 in this example. So good stuff here, right? Now, you know what a Pearson correlation looks like, right? You've used Pearson correlations before. This is that perfect correlation I was talking about, right? Jody, Jody, Kara, Kara, Monta, Monta, Chris, Chris, right? All the way down. This is the correlation between Jody and Monta. This is the correlation between Kara and Monta, right? So they differ as you go across, but you'll notice they become repetitive. So 3 and 1, and 3 and 1, if it was right here, would be the same. Essentially, y'all, I know correlations is a pretty simplified understanding of statistics, right? It's how much the types of relationships variables have with each other, but that is going to continuously be something that we have to look at whenever we look at our data. So these are the 8 example items I presented to you at the very beginning, right? Statistics scare me, blah, 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 blah. So how correlated are they with each other? Notice that there are negative correlations and positive correlations here. Some not so strong, right? 0.2, or negative 0.382, all the way up to 0.5, right? Pretty strong. That's important to know because that's what we're trying to do, is figure out what items measure SPSS anxiety. Like how many essentially how many constructs are we measuring with this questionnaire? Because we're trying to measure SPSS anxiety, but if all 8 of these items don't adequately measure it, then they're gonna differences here. We talked about communality, and what we mean, it's a simpler term for common variance, right? It's essentially the amount of variance that is shared among a given set of items. So it ranges between 0 and 1. It does not go negative. Variance is not negative, if you remember, right? Variance is always a positive number. But when we see communality calculated closer to 1, it means that whatever factors we're looking at explain more of the variance for an individual item, right? If we see this measurement of commonality really close to 1, it means that the variance is being captured with that one item, okay? There's a couple of different ways to talk about variance. So this is unique variance, right? Basically, this is a concept that means it's not common, right? It's not shared variance. For example, you've got that item that all computers hate me, right? Is that really related back to SPSS anxiety? Or is it maybe variance that has something to do about anxiety about computers in general? Maybe someone just always has trouble even getting into Microsoft Word or Excel, right? There's other factors at play here. And so even though someone with anxiety about computers may also have anxiety about SPSS, that means that it's probably not specific to one particular item, right? So 2 of the terms, and these are very similar, so let's drill them into your head. 2 of the things that we look at with an exploratory factor analysis are eigenvalues and eigenvectors, okay? I'm gonna let you figure out the best way to figure out the differences here. But eigenvalues are the total amount of variance that can be explained by one component, the one set of items, essentially. Eigenvalues that are greater than 0 are good. But if you have an eigenvalue that's close to 0, that is representative of what we call multicollinearity, which you all know what that means, right? It's when factors are basically correlated highly with each other. And so it creates a value that is not very large. So again, eigenvalues, variance. VA, right? Variance values. Maybe that's one way to do it. Eigenvectors represent the weight for the eigenvalue. So essentially, what's the correlation of the first item with the first component? We're going to fill that blank in here in a little bit. But what you need to know here is that there's ways of calculating it, but all this is going to come out in SPSS. What we need to know, we don't necessarily need to be able to explain this in our write-up for individual items. You might, especially if they're pretty highly correlated or highly representative. But what we really need to know is how to read it to make a determination of which items are factoring together that represent the construct that we're trying to measure. Okay, so remember burnout, right? Lots of different items that measure burnout. Well, what if I told you that the number of, or just traffic, traffic was really bad going to work today, or really good going to work today. The levels of traffic on your commute may not have much of, they may not account for very much of your feeling of burnout because they vary so much, right? So more than likely, we might have items that are stressful but don't really factor into burnout, kind of as a separate component, and then items that are specific to burnout all factor together. Okay, we'll be seeing a visual of this here in a little bit. I think it's important to kind of talk through this part first. So that's kind of your intro to the terminology. When we want to do a factor analysis or an exploratory factor analysis, the first thing we want to do is reduce the number of variables, right? That's the primary reason we perform factor analysis. Reduce the number of variables to explain something. And then we need to be able to interpret our results. So how we do this is 2 steps. We determine how we're going to extract our factors. Principal components analysis is how we're going to be doing it in this class. This is the type of the model, as well as the number of factors to extract. Again, we'll get to that point here in a minute. And then to Kara's question earlier and tonight's theme song, you spin me right round, baby, right round, like a record, right? Factor rotation, and it's important here. So here's the thing. Even though we might think we have maybe 2 factors that are being calculated here, 2 groups of items that measure maybe 2 different things, the way they fit on a 2-dimensional plane on the X and Y axis may seem very different. However, Kara, this is important, so make sure you're watching, especially since you asked about it. What happens is, what if we rotate? All of a sudden, on a 3-dimensional plane, they are actually more in line than they are apart. Think about, if you're in a store. So let's just say, I don't know, what do y'all have where you are? Do y'all have Dillard's or Macy's or whatever? Where do you shop?
Macy's.
Macy's. Okay, cool. So let's just say I'm in the perfume section. All right, I went to a Belt for the first time in like 2 years this past weekend after we had Chinese food, and we went in Belt. It's got, and I assume a lot like Macy's, right? It's got multiple floors, right? So when I walked in, looking out, I knew that the home goods were on the 2nd floor. So just kind of thinking about it from a 2-dimensional plane, they were pretty far away, right? But if you think about where they are in terms of directly above my head, right? Even though they're on the 2nd floor, they're actually not that far away from me. But if I wanted to go from perfume to towels, if I could just float up right there, I could have been there in like 2 seconds, right? But oftentimes when we perceive the distance between items on these, on what you'll see is, this rotational factor plane, if it's unrotated, they may seem farther apart than they really are. So what we do, and y'all, this is not easy to understand. Let me just go ahead and make you feel better, okay? What we do is we tell SPSS, I want you to rotate our analysis as many times as we tell it to, like 100 times, right? And basically figure out the best fit for all of these variables to be able to explain one or two different, however many we have, different factors that explain burnout as a whole, okay? Or SPSS anxiety, okay? So I told you about principal components analysis. That's what we're going to focus on here. Essentially, what we know is that, remember how I told you earlier that we look at that correlation matrix and we saw the factors that were, or the items that were positively correlated with each other, negatively correlated with each other? Principal components analysis tries to replicate that matrix using a fewer number of items and combinations of the original set of items. So we're essentially trying to, again, reduce the number of questions that we're asking, right? In order to come up with those same correlations as we did before. So this is part of the output. This is part of the output. So remember, eigenvalues, right, explain the variance, VA, values, variance. Eigenvectors, what do those do?
What's the weight?
The weight, exactly, right? So here we go. Here's our initial eigenvalues. One of the things, and I'll go ahead and tell you now, one of the things that I was taught in an earlier class, in my first master's degree, was that we should always go with whatever items load onto components that have, this is components, right? Whatever items load onto components that have an eigenvalue of greater than 1. Okay? Anybody read that in the book already?
Say that one more time, or did you say one or more?
Yeah,
I'm
sure.
having a hard time understanding today.
No, it's okay. And hopefully audio is being recorded tonight.
I'm talking about just words in general.
Oh, yeah, words are hard. Math is hard. This is the hardest. So, yeah. So from an early point in my analysis career, one of the first grad classes I had in statistics, the professor said, "Oh, I don't know about that, Chris."
Oh, okay, because that makes it easier. Sometimes I can just see the words. Like sometimes words just are muffled sounding to me, and I don't know if it's my system or not, or my. But yeah, just go ahead. Oh, it's working.
I see that, and I don't know if it's going to pick up on my Mississippi Gulf Coast Southern drawl. That's more of a maybe Brad. Yeah, maybe Brad. Maybe Brad.
Sometimes it'll go back and correct it. But anyway, it's a help.
Can I just turn it off so I don't watch myself talk? This is weird.
Yeah, you can turn it off.
I'll figure it out.
Thanks.
No, I'm not going to turn it off for you. I want you to have the resource, Chris. I just don't want to watch my own closed captioning.
I totally get it. Thank you.
Yeah, you're good. All right, no problem. Okay, so early on, the idea that was given to me was anytime you have a component with an eigenvalue greater than 1, that's what you do, and that's how many components you end up with, right? So here, this is just an example of 8 different components. We had 8 questions on that sample questionnaire. So essentially, the first 2 actually explain more than half of the variance in the entire data set when compared to each other, right? So interestingly, right? Now, again, this was a forced 8 component solution. That's what we call it. How many factors you want to produce is an 8 component solution or two component solution. Hopefully, you know when you have a set of questions, how many constructs are you measuring, right? If we were going to talk about burnout, we could talk about burnout with regards to COVID-19, right? And that is more than just our own health, but also probably our interactions in the community, right? But then there's work demands, right? So you see what I'm saying? These are all different constructs that we can measure with burnout. So think about that as we go through. Or actually, this week's assignment should help you think through this, because you're going to have to do, skipping ahead, a literature review for exploratory factor analysis and understand how people are using this to reduce items. So part of the output in SPSS is going to give you what's called a scree plot and the component matrix. So this, remember how I told you, anything less than one, former professor said, you know, but none of these are valid or, you know, usable. But look at the difference between 1 and 2. The difference between 1 and 2. 2 is a lot more like 3 and 4 than it is 1. Chris.
Okay, so I just have a question. What if, by chance, those first 2 questions they didn't think of or they didn't have, and you say, would the scree plot change for questions 3 through 8? Possibly, would those skew up a little bit higher because you only have these questions, or would they generally still? Do you think that they would stay low, below 1?
No, that's a good question. So remember, it's what the questions are asking. So actually, this is a great time to get you to look at the component matrix over here on the right. Do you see that, y'all? Mm-hmm. I hope you do. I don't think I put animation on this one. So yeah, okay.
Yeah, it's there.
So look at that. Statistics makes me cry, right? My friends think I'm stupid for not being able to cope with statistics. Standard deviations excite me. This one makes sense. Does this sound like anxiety about statistics?
No, not negative anxiety. No. I mean,
it's yeah, no, yeah. So for this one not to fit, like, which one of these is not like the others, right? That one's not like the others to me. Pearson attacking, I don't understand, little experience, math and computers hate me, right? All of those have negative connotations, but this one says they excite me. So notice over here, I don't know why my friends will think I'm stupid for not being able to cope with SPSS, is also in that same ballpark, but hey, it's the example data we were given. But look at how low all the others score on this second component, right? So basically what's happening is we're looking at how each of these fit with each other in a variety of ways. And this 2-component solution basically says these 2 go together, and this one, that one, that one, that one, that one, and that one align better.
Okay, I'm sorry, I'm not understanding the little bar chart. Here. Okay, so 2. Hang on.
Yeah, what about it?
I'm sorry, I'm trying to think how to ask this. So at the top where there's the 3.
Yeah, here we go.
Okay, so we're looking at, okay, I gotcha. Okay.
Yeah. Does that make sense, Jay?
Yes.
So basically this is charted out here. This value is 3.0 whatever 67. That's 1.0 whatever. That's 0.9 whatever. Yeah, 3.057. There.
And the matrix is only showing component 1, how 1 and 2 to the rest of everything else. Are there 8 questions?
It forgot about the rest of everything else because it's got that, you know, if it's an eigenvalue greater than 1, it holds it. Otherwise, it lets it go.
So if I was trying to, just so I will remember it if I see this, I think. So it's saying those top two components that seem to have that do have the highest value are 1 and 2. So you plot them on the matrix here as 1 and 2, and then all of the questions 1 through 8 on the left. And then that is where you do the it's showing a comparison of the variance between component 1 to, I don't know what the top ones is. Question number 1 or component 1 statistics make me cry. No.
Component one is how all of those fit together. Component 2 is in a different rotation, how all of those fit together.
I got you.
And you see that they are not fitting together. If we continue to do 100 rotations, essentially, we're going to see less and less kind of absorption of all these coming together. So this is where we find the most differences, but still the greatest variance explained. So remember, percent of variance explained, we had 38% of our variance explained by that one component. And then with the other one, the second one, about 13% more. And then 3, it goes down and down and down and down. So what factor analysis is doing is it's helping us understand the different ways in which items vary together, the different ways in which items have relationships together. And if we made this go out to all 8, Chris, you would continue to see lower and lower values for all of those. And so SPSS helps us to say, okay, we've got 2 constructs here, 2 components. Let's try to make sense of what those are and see if that truly is measuring what we intend for it to measure. Go ahead, Jody.
So sorry, the component on the component matrix 1 and 2 are not the same thing as 1 and 2 on the prior slide. Statistics make me cry. My friends will think I'm stupid.
Or the components are the.
They are the same thing here, but they are not the question numbers. They are how those questions relate to each other. Okay. So maybe we're getting question number and component number mixed up a little bit. Is that fair to say?
Yes.
Okay, look, in component 1, we have values for every question. In component 2, we have values for every question. The difference is component 1 shows us the most effective way of measuring the variance across the entire 8 questions, right? And it found that, well, I'm just going to say question 1, 4 through 8, question 1 and questions 4 through 8 all factor together, all relate together, right? But questions 2 and 3 seem to be much stronger together. And that shows up in component 2 because they can't show up in component 1 because they don't relate to the other, 6 or so. So the way we do it like this, y'all, is not to be confusing, but to show you where there's disassociation, right? And then in component 2, you expect to see those higher values for those 2 show up. Now, every once in a while, let's just say this one being 0.568 down here at the bottom. I've seen it to where it's like 0.568 on component 1 and like 0.4 on component 2. At that point, you're like, okay, which component does it need to be assigned to, right? Is that question asking more about, I don't know, statistics anxiety or statistics love, right? And so this is when we get into this item reduction of being able to figure out what constructs are we actually measuring here? And is it a valid question? Does it make sense? I'll be honest with y'all, there are parts of statistics that are very cut and dry. This is not one of them. Sorry, Kara.
No, I was going to ask an easy, well, maybe it's not an easy question. So when I'm looking at the table, what my brain thought was, okay, for example, component 1, that column, I'm going to pretend that is statistics stress and how these things correlate to statistics stress. And that the column for component 2 is how these things correlate to, I believe one of the examples in the book was social anxiety. So in component 1, statistics stress, the 6 questions that have high numbers, those are all statistics stress indicators. And so they have higher variance numbers, right? But then under the component 2 column, that's more about social or computer anxiety or something. And so those have the better numbers over there. Ish.
And I heard you say variance, but I think you meant eigenvalues.
I'm sure that's
right?
Yes. Definitely one.
Yeah, which is, of course, the measure of variance between items.
Yeah,
right?
yeah. I mean,
So these vary together. People who say statistics makes me cry, people who are strongly agree with that statement are also very likely to say that they dream of being attacked or they don't understand statistics. People who say standard deviations excite me, for some reason, also have coping mechanism issues with SPSS to some degree. Does that make sense? Think of it like a correlation matrix. But people who say standard deviations excite me do not say that they don't understand statistics or any of these other things, right? And so, and I'm going to show you a way of seeing this play out in your data set, because remember how we saved the Cook's distance and the standardized residuals? We can also save these factors into our data to help you see it. So let's get a little deeper into the eigenvalue. It may actually help us come out of any confusion. So how do we get from a component matrix to variance explained? Okay. All you have to do is square each of these values, 0.3 squared, 0.653 squared, 0.720 squared, but sum all of them together. Sum all of them together. And I promise you, it's going to be 3.057. Okay. Don't believe me?
Kind of magical sounding.
Well, dang. Oh, here, yeah, duh, square. No. How do we square things in Excel, y'all?
I don't remember the formula.
I think I did a caret and a 2.
Okay,
Oh, yeah.
that'll work. I'll just do this.
And the sum of squares is not the same as squared sum.
No, yeah, good point. But no. What does that say down here?
Wait,
3.05.
7.
Eigenvalues. Okay. So we have these, right? We have these guys right here. We squared and summed them together, right? Eigenvalue. And now all we have to do to get the total variance explained is divide it by the number of items. How many items do we have?
8.
Percent of the variance explained. Okay. Are you processing?
So when you 38%, 38.2, whatever percent explained, say that in a sentence.
Yeah. So these 8 items and that were factored together in component 1, even though there are differences in negative values and that sort of thing, those 8 items together in that one rotation that showed essentially the greatest amount of variance explained was 38.2% of the variance for the entire model. And remember, it's like a correlation matrix, right? So expand this all the way out, and expect all of these to be placed on each other, right? And that's all the variance that can be explained. But we can explain 38% of the variance just by these factors, or these factor loadings rather, that basically give us these values. So this is, go ahead, Jay.
But what does that have to do with the stress? Like if you're trying to explain that, all right, say you're trying to explain this to my husband, like where does the stress part come in?
Yeah, I like that idea. All right, so
And this is way more than a one bar. Okay, I don't know why you got that one colored bar up there. Like that's a lie.
Oh, it meant to be that one.
Yeah.
Sorry. Yeah. Well, actually, no. This is one bar. This is one bar. This is just looking at the output. This is I'm putting it into words, right? So how would I explain this to your husband? I would say, honey, that's what you call him, right? Honey pie. You know, when we looked at 8 different ways of measuring statistical anxiety, 6 of them really seem to measure, you know, stress related to statistics, and the other 2 did not. The other 2 that just did not seem as strong or as correlated with the others. And so we actually ended up with 2 different constructs in our questionnaire. One that really does focus on statistical anxiety or statistical stress and understanding, and the other one that focuses on coping and, I don't know, excitement, whatever. Again, this is just 8 items, so we don't have the full thing here. Okay. So I want to go back to this eigenvalue of greater than 1, right? Remember I told you that was what a former professor of mine said. The other way of thinking about it is, everybody know where your elbow is? Where is it? Right? Can you find your elbow? Good. Find your elbow. Where's your elbow?
1, 2.
It happens to also be above 1, right? But it doesn't always work out like that. Doesn't always work out like that. Generally, it's at that elbow that there's a lot more flattening, right? And a lot less difference between the factors. So I'll let you choose your own adventure for that. Now, Kara, I'll let you take it over from here.
No, thank you. This is the one that's confusing to me, unless you want me to do my club dancing right now. that's
Before you go, I'm still not satisfied with the sentence, the 38%. So 38% of the, not of the variance. I want to, like, don't use the words in the definition for me. Like 38% of those 8 items, or of those 8 components.
Okay. Yeah. Hey,
I'm sorry.
There's always going to be variance within any amount of data that we collect. Mm-hmm. When we run a logistical regression model, mm-hmm. and we talk about what's the likelihood of you figuring out exploratory factor analysis in an hour and a half, right? Mm-hmm. That likelihood is whatever it may be, you know, there's going to be variance between everyone who takes that survey. And the thing that we tried to do in linear regression was explain as much of the variance as possible, right? We wanted to know what factors were related to, you know, income, right? And so we looked at education levels, we looked at where you live, we looked at what your parents' education level was, right? All this other stuff. What we were able to do in modeling in the linear regression models was explain a certain proportion of the variance, right? If we got even 50%, we were excited. Well, here we know how much variance there is in this data because we have the data. And so what we do with basically with these eigenvalues, trying to maximize the amount of variance that we can explain with as few factors as possible. Okay. So instead of using all, 8 factors with 8 different combinations of things here, we can just use 2. We can just use those 2 with those weights, right? Eigenvectors, we can use weights to be able to explain variance and be able to figure out how likely it is that that person's gonna, be strongly agreeing with statistics freaks me out, right? We're going to have a chance to play both in the journal literature as well as in the data, so just bear with me. But we are at, well, we'll try to confuse you even more for a second, and then we'll take a break at 1:30. How about that? All right, so rotation. Remember how I told you, walk into the store, and if you only look at it on a 2-dimensional plane, you're pretty far away from everything. But if you rotate, right? If we revolve over, if we spin you around, right? Then things tend to improve. You might actually see that what was thought to be. Let me actually squirrel. I don't think I have any of those here. Yeah, we'll show you in the example. What was thought to be kind of on this 2-dimensional plane, when you flatten it out, it actually may be closer. You may actually improve your assumption of how far away things are from each other. So there's 2 different types of rotation. One assumes that our variables, our factors are independent and not correlated with each other, right? And that's the typical method. And that's the one that we're going to use for our example. And I just want you to remember Varimax. Varimax is one orthogonal rotation method. And it's easy to remember because it maximizes the variance. Don't you love it, Chris, when they use the definition in the term? Varimax maximizes the variance, right?
But I think
It
of
maximizes the variance. Oh, you're a IMO Maxinista. Yeah, I'm a IMO Maxinista. That's where we go after we have dinner most of the time. TJ Maxx or Home Goods. But anyway, Varimax, what it does is it tries to maximize the differences. It tries to get them as far apart as possible. So if our factor analysis thinks that items 2 and 3 should be close to each other or are close to each other, and 4 through 8 are also close to each other, it's going to rotate all different ways to be able to maximize the distance between the ones that are different. So higher loadings are made higher and lower loadings are lowered, right? If you have a model solar system at your house, give it a spin. You know what I'm saying? Sometimes the Earth is closer to, certain things than it is others. Okay, that's orthogonal. Orthogonal, again, independence, uncorrelated variables. Oblique rotation does not make that assumption that they're independent, but it thinks that they are possibly correlated. We're not going to give you an example of that. We're going to assume independence because that's generally where we go with most of our other modeling in this class, is we always want to assume independent observations, right? So just want to introduce it, but don't want you to have to freak out about it. All right, you know what? We're here. This is what we're going to do in SPSS. So why don't we go ahead and take 10 and come back at 36 after. You ready for a break?
Yes, thank you. My watch keeps saying stand up.
Do a sun salutation.
Eric, is that slide like all the steps in SPSS?
Yeah, I went ahead and did that for y'all in case the recording screwed up again.
It might be one of my favorite slides I've ever seen. I love those. They make me so happy.
I'm sorry, I was talking with it on mute. I said, I know we really don't have time, but I'm always curious what everybody did on their break. Did they really relax, or did they do like, because I just cleaned up the kitchen, made a cup of tea, helped my son make his lunch.
Same. Took the dogs out, loaded the dishwasher.
Okay. That's what we do with our break, Eric, just in case you're curious. But it makes me think of
You
that
don't
show.
want to know what.
What'd you do?
He ate a sandwich.
Okay. No, I did that off camera while y'all were in your groups earlier. No, during the break, this is what I do every time. I go and I talk to my wife for a few minutes about her day, our day, whatever else we need to talk about. And then I get the dog food bowl. I put food in it. I put a little chicken broth in it because our boo-boo is 11 and he needs his food softened. And I literally dance, like, shake it up. And I do all this crazy stuff because he gets excited when I dance with his food, and then that makes him want to eat. He will not eat if my wife does it because she doesn't dance.
You tested this. No dance, no eat. Nothing like a good question. Get somebody to do something. Yeah, I got to buy dog food tomorrow. I'm out. Almost. I got enough for tomorrow.
Hello.
Does Spinner eat his food if I don't dance?
No.
Does he eat food when you feed him?
Sometimes, but rarely.
Do you dance?
No.
Okay. So I'll catch that.
Okay, I don't know if
Poor wife.
I don't know if that's statistically significant, because off screen it could have been your wife, your version of your wife's voice.
Voice. That is very true.
Yeah. No, that was her voice. That was her voice. All right, y'all. We don't have much time left, so let's work. Okay.
Boogie.
All right. So Kara said she likes this. I did it in anticipation for technical difficulties. Analysis, or whatever, analyze. Dimension reduction. Key words there, right? We're reducing the number of items. So dimension reduction factor. Descriptives. We want the initial solution. We also want the coefficients. We also want significance levels for those coefficients in the correlation matrix, right? Again, we want the anti-image and the KMO to know, right, if there's sample adequacy, okay? Remember that word, sample adequacy. Hit continue. We are going to bring all 8 items in. I just hit shift and clicked the very bottom, then brought them all in. For extraction, we're going to extract the correlation matrix. We're going to use principal components analysis, right, method, where we want the unrotated factor solution to kind of see what it would have looked like had we not rotated it. We want to show the scree plot, remember the elbow? And we will set our maximum iterations at 100, because why not, right? That's a good number to know. The extract, this is that based on the eigenvalue greater than 1, or you can tell it a fixed number of factors to extract. And if, going back into theory, right, if your questionnaire in theoretical terms should have 4 factors, well, if the 4th factor has an eigenvalue of less than 1, if you tell it to pull 4, it's going to pull 4, right? Even if the eigenvalue is like 0.7, right? And I mean, that's just the way theory works. If you know you should have 4, it's going to go ahead and pull 4 if you tell it to. Let's just keep it based on the eigenvalue greater than 1 here for simplicity. Hit continue. rotation, Varimax, right? Because it is what kind of rotational? Is it orthogonal or
Diagonal.
the other? What does that mean?
That there are some
Independent.
Right, it assumes independence and uncorrelated variables, right? All right, so we'll do our loading plots. Apologies if I didn't put that on there, I didn't. That's the plots that show kind of where they land. And then we'll do 100 here also. 100 rotations as a server. All right, ready? Continue. And then scores. I'll add this back to the note to the slide before I'll repost it. It's already posted. You can also save variables for like the regression model and that sort of thing, and display the factor score coefficient matrix. Not the biggest deal. We don't need to exclude anything pairwise, but we will exclude cases listwise. What that means is if we don't have all of the item scores for all the items, then that one response will come out. Okay. So if someone entered item number 3 but not item number 4, that person is taken out of the sample. And that's usually the best practice. Okay. So let me again work through this just a little bit to make sure I have everything. Let's go ahead, we'll save it anyway, just to make sure. I think that's what. All right, ready? Okay.
Paste.
We're gonna get a lot of output here, y'all.
Oh my God.
So first thing we see is a correlation matrix, right? And that's good. We need to see the correlation matrix because we need to know if our factors are correlated with each other. And we want them to be correlated with each other because we want them to factor together to some degree. But we also recognize that some are not, right? Positive correlation, negative correlation, all the way down. Okay. The KMO Bartlett, you remember, if it's greater than what? It's good.
0.5. Well,
Yeah,
no,
well, 0.5 is kind of the
yeah, no, greater 0.8 is good. 0.9 is yeehaw.
yes, yeehaw. 0.8 is great. 0.5 is minimum acceptable, right?
Mhm.
All right, anti-image matrices. What are we looking for here?
Just the greater than 1.
No, we want the diagonal to be close to 1, and we want all the non-diagonals to be very low. So
Okay,
the diagonal, statistics makes me cry versus statistics makes me cry, close to 1, close to 1, close to 1, not so close to 1, right? But look at all these others, very low, except for, oops, there it is. No, that's the next.
yeah. They should shade those. That would be better.
Yeah, that's very hard.
Especially when
well, I
some
know
of
it's hard for y'all to see it.
Well, the rows are not all even.
So you're just
Yeah.
going like stair step, bop, bop, bop. That was
Bop, bop, bop,
Okay.
bop. Yes. That's going to be fun to see on the transcription.
Sorry.
So anyway, so hey, look, our assumptions, sample adequacy, we've met them, right? Now let's go look at our commonalities. So here's just the initial, it makes the assumption of everything is related, but when we extract, we find that it's not, right? So that's all, I mean, that's not the most important thing to look at. This is where we come out to our total variance explained. You've already seen this, right? And you know how we got it. Because you can take each of the items in the component matrix I think a little further down, there it is, right? Square them and sum them to get the eigenvalue of 3.057 or 1.067. So you know where the eigenvalues are above 1, but you also know where the elbow is, right? Now look at that. Here we have an unrotated component matrix. Now we have a rotated component matrix. It only took 3 iterations. How many did I tell it to do?
100.
100, right? So in 3 iterations, it maximized the difference between the high and the low, right? It maximized it. So look at this now. Initially, we were at like -0.3, -0.65. Well, this one's still negative. This one's now considered a positive value. But look at the differences here, right? Look at the differences across the components. Quite a bit, quite a bit. All of these are negative except for the very last one. But before, I don't know if you saw, this last one, I've never been good at mathematics, was actually a 0.267, and not too far away from standard deviations excite me, not too far away from it. Now it's about there's a difference there of about 0.6. Do you see that? The differences have been maximized because we've done these rotations. So this is what I told you we would eventually see visually. Item 1, 4 through 8. Look at how much they group together in this space. These two aren't too close, but they're a heck of a lot closer than they are to these, right? And this is the rotated solution. So now that we've seen that, we know we have 2 factors, right? Oops, apologies, I did not mean to minimize. There we go. Look at that, factor 1 and factor 2 scores. Remember, I went in and I saved the regression scores. That's what this is. So based on the combination of all of their responses to these 8 items, this person's factor 1 score, this person's factor 2 score, right? So they're probably more on the factor 2 side. Oh, wait, no, apologies. To look at, I can't see the decimal points, y'all. I know they're there. I can't, if I can't see it, I know you can't see it. But here's the thing. A lot of difference, right, between 0.29 and 1.13. Not a lot of difference between 5686 and 42882. Not a lot of difference there, right? So remember all that variation that we're trying to account for, we're seeing it on an individual response basis here. Go ahead, Kara.
Does the negative or positive matter to us at all?
No, what matters is the differences between the two at this point. So here's one, -2.99, right? They are strengthening the differences between factor 1 and factor 2. What I would expect to see on all of these, if you look at all of them, I mean, you know, there are probably thousands. Yeah, there's thousands of responses to this thing. Is that generally you're going to see differences between those 2 columns more so than they're going to be alike, right? Because that's the whole purpose of this, is what are we looking at? We're looking at understanding what we're measuring with these 8 questions. Are they all measuring the same thing, or are they measuring different things? According to SPSS, they're measuring 2 different things, 2 different constructs. Okay, so last week I told you we were going to talk about communality, factor rotation, or abstraction rotation. You know what this is. I don't have to explain the lit reviews for you anymore, I don't think. That is this week. Oops, that's the Titanic. So I want you to make sure that they account for independence, multicollinearity, sample adequacy, right? All the things we talked about tonight. Next week, we will get into chapter 11. So we're just about a week behind on the reading side, but go ahead and start reading on it. We're going to introduce it slowly, kind of like we did this one. And I like this approach, y'all. Do y'all like this approach? I'm not just throwing this at you in 1 week and expecting you to figure it out in 1 week.
Yeah, I do.
But next
No.
week's assignment, I'm going to go ahead, Chris.
No, I said yes. Thank you.
No problem. Next week's assignment, just to give you a heads up, is going to be using the full SPSS anxiety questionnaire, not the 8 items that we looked at today, but the full one. Okay. Would you all like me to go ahead and give you access to that full questionnaire? Just
Yes.
to let you start looking at it. Okay. Anybody else?
Sure, that's fine. Are we going to give this questionnaire? Are we going to actually like administer this to somebody or people?
No.
Oh.
No, what I mean is you're gonna you're going to get the data set with all the 23 items on it with thousands of responses. Okay.
Oh, the data set. I just thought you were giving us the questions. Okay.
There it is. You should all have it right now. Check your chat.
Chat. There you go. I haven't done this in Zoom
Everybody-
yet. Attach something.
Oh, I like it. I mean, it helps me not forget. But does everybody have it downloaded or saved?
I don't know where I just saved it. Yeah.
So what do y'all think about the questionnaire as a whole? Let's take a look just to kind of think about it. I know it's harder with the 8 items. We've already seen the items 1 through 8, right? My friends are better at statistics than me. Computers are useful for only playing games. Badly in math. People try to tell you SPSS makes it easier, whatever. Just by looking at this questionnaire, I'm seeing 3 things pop out of my head. What do y'all see? How many factors do y'all think or see and when you read it?
Computers, just view of computers. Then there's SPSS. Comparison to friends. Is that what you mean? No.
Not so much.
Well, you got 2
What are
fingers
they
up.
comparing themselves? I'd
Oh.
have 2. I'm waiting on y'all for the 3rd.
Okay, I'm powering down mentally. Maybe I was already there, but go ahead. Somebody else, anybody.
Well, I was thinking in my head, and so I don't know what was already said. There's fear of statistics. There's some kind of social thing happening, like social fear. There's like, I'll call it hardware, like computer not loving technology in general seems to be a thing. And then this one about I've never been good at mathematics and I did bad at math. That's some kind of like personal assessment situation, like, I don't know, resilience or confidence or something along those lines. That's what I'm seeing.
Yeah. Okay. What do y'all think? Who else wants to jump in?
Is there one answer, or it could be your interpretation?
We're going to find out. Jody, that's what we're going to do. We're going to do a factor analysis to see what SPSS tells us based on all these variables and all those responses. Make sense?
Okay, so you can take something like this then. This excites me for this reason. You can take a survey for something that is basically a latent kind of variable. Go through this and determine if it's a trash survey or not. Can you? I mean, like point blank, basically, you can say this is just not great. Can you do that?
Yeah, I wouldn't call it a trash survey. That's a little harsh, Chris. But you're right. It's getting late. I'm
not saying this is. I'm saying, but
no. I would think that what you might want to be able to do is say these items aren't coalescing in the same way, in the way that we anticipate them to do, right? So the way just in case y'all are wondering, what I saw initially when I first read this for the very first time, I saw just general constructs, not looking into friends versus fear and all that kind of stuff. I saw computers, I saw math, and I saw SPSS, right? But that doesn't mean that that's it, because there's SPSS and then there's statistics. And I wonder how much SPSS and fear of computers interplay together. Because SPSS is as much of a computer issue as much as is a statistics issue, right? So that's why I want y'all to play with this data next week. Okay. Sound good? First, learn more about factor analysis. Find an article that you're interested in to be able to better understand and connect with it. I know
Before
we're
we tell
getting close
you
to time.
what those variables are, you wanted us to bring.
What do you mean?
You said
What variables?
we wanted an example of latent variables, and then would that be something that would help us to find that article?
Yeah, exactly.
Okay.
Sorry, I was about to go out there and I was like, wait, what did I say earlier? Like 10 minutes ago. You're talking about last week, right? Yeah.
Yeah.
Those latent variables. What I would do is Google or library search or whatever you do. If you're interested in student burnout, right? Put that in search and factor analysis. Boom. Knock it out. Be careful. There is also a confirmatory factor analysis. I don't want you to learn about that yet. I want you to specifically stick with exploratory factor analysis. Okay?
Okay.
Cool.
Okay, I just want to make sure it says that in the
Yes,
header of the assignment. Great.
exactly.
And that's generally going to be called out in these articles that we find. It will say exploratory.
Yeah, they should say. They should
Okay.
definitely say.
Okay. Great. Can I mention that I was listening to NPR a couple days ago, and I wrote this down because I thought it did apply to a latent variable, but there is a lady who wrote a book, and then she did some studies on loneliness and heartbreak. And that was like, how do we measure that? But she also tied it into how it affects your, physical well-being, like your physical well-being and that kind of stuff. But she wrote a book, and I can't remember, heartbreak and loneliness, but she did actually go to a researcher who is a biological anthropologist that studied the brain after being dumped. So anyway, those were the terms they used too. But anyway, I just thought I thought it was crazy that we had the last week's session, and then I would hear that on the radio.
Cool. Anybody else think about latent variables this week?
Yeah, I'm going to be doing critical thinking dispositions.
Okay. For who?
What do you mean for whom? The studies that I found are all on university students. Yeah. Is that what you were meaning?
Yeah. So you could do it on the elderly, the imprisoned, right? You see what I'm saying? Lots of different populations.
Yeah, I didn't get
Cool.
as far as what I thought I would. Are you asking us what we're going to do?
Mm-hmm.
Oh, I don't know. I got to look. I mean, I wrote a bunch of them down. I wrote introversion, extroversion, confidence, quality of life, stuff that we talked about, satisfaction with something or the other. I don't know. Like I get in there and first I type in explore analysis, and then I look at the subjects. I'm like, that sounds interesting. I don't go for a subject and then I want to find the damn article. And like, I'll make it be interesting. I go the
That's
reverse.
okay too. Yeah. So, everybody good on their presentations? Is everybody good on their assignments? Assignment. Is everybody missing that second assignment? Is anybody missing that second assignment each week?
Second assignment. Oh, we were supposed to have 2 assignments this week. Craptastic.
Last semester, we would do a lit review and a lab every week.
No, we're,
And Jody and
that's-
Chris did a lit review in the lab every week last year.
Oh, okay.
Yeah, I thought there was something that you put on this and you're just scratching it. That, no, this is good. This is good.
we don't need any more. So the data set that you just gave us, you want us to do that to turn in for next week, or we'll do that in class next week, or that's just for us to have fun with?
No, you've got the week 5 data demonstration, which is the right here.
Right,
All right, that's the 8-item questionnaire we talked about tonight, right?
right.
What I gave you tonight is the full 22 or 23 item questionnaire. I'm going to build an assignment off of that for you next week that you're going to turn in the following Tuesday.
I
I'm just giving
understand.
it to you now to let you play with it. Okay.
Thank you.
Okay.
Stop.
Yeah. What do I need to stop?
That was not directed at you. That was the dog. Sorry,
Oh.
going through the trash. I'm so sorry.
It's okay. All right. Sorry, y'all. All right. So, okay, cool. Well, anything else?
Oh,
Or to go to the
lit
order?
review, the lit review, the extra time to go back and do whatever we need to the magic on the, which basically is the whole thing for me. Because I didn't combine the two.